Okay, precision and accuracy. So generally, those two words are pretty similar, but they have some of the difference over here. So if you're looking at the graph shows over here, it definitely shows what is the precision, what is the accuracy. So in general, if you're looking at this one you have quite a lot of the dots and all together, but it's far away from the target. So this case is called a very precise. So precise, generally it talk about if you have a lot of the data, okay, those data is repeatable. That's called precise. Okay, if those data is repeatable, that's precise, but not accurate. Accurate, that means it's close to the center, which is the target. Okay, if the data close to the center, that means it's accurate. Okay, so that is why this part is called accurate and precise. So not just precise, but also accurate, because all of those data you have is aggregate together, which is very close to each other's, and also is very close to the target number. Okay, so that's called precise and accurate. Okay, yeah. And if you're looking at this is called as a precise. This is accurate, but not precise, which means each of the data still close to the target, but it's not repeatable, which means each of the data is scattered. Okay, it's not repeatable. So this is not precise, but still accurate. And the last part is not accurate and not precise, which means the data that's going to be everywhere. You cannot see, it's everywhere. It's not close to the target, and also it's not aggregate together. So not precise and not accurate. Okay, one of the example is probably something like that. Okay, for example, our textbook, the table. If you're looking at the table, the length of the table, we can measure it. So it's about 152. Okay. Yeah, 152. But let's see. This table is coming from the industry. The industry in the instruction manual, they should already give you the dimension of this table, right? Yeah. Let's see, the dimension of the table from the industry is called a 150 centimeter. 150 centimeter. Okay. But if we have several people come over here, they measure it. One is measure 152.1 centimeter. One measure is a 152.5 centimeter. The other one is a 151.9 centimeters. So those are the three persons who measure the length of this table. And then you will see those three data actually is repeatable. 152.1, 152.5, 151.9. Not too far away, right? It's close. So those data are repeatable. So that means we call this is precise, because those are data, a set of data is repeatable. But we cannot, if you compare this data to this data, then it's not accurate. You see, target, this is target, which is the data already have from the industry. And this is set of the data that the people studied, people measured. This set of data is not matching the target data. So that's why this is not accurate. Does that make sense? Right? Yeah. So just something like this. Just something like this. Is this data you measured is precise, but it's far away from the target. So that's why we call this is not accurate but precise. That makes sense, right? Yeah. So those are the difference between accurate and precise. That's the difference between accurate and precise. Okay, yeah. So this is our first knowledge. Okay, and then we're going to talk about the next one, which is called SIGFIG. Okay, significant figures.
So that what it says?
Huh? Significant figures. I think I. Also called SIGFIG or SF. Okay, so those are the same thing. SIGFIG or SF. Significant figures. This is one of the rule for looking at some of the numbers. Some of you probably already know it. Okay. First, I'm going to say talk about why SIGFIG is very important. Okay. Yeah. For example, there's one day I drive back home from Dallas to Wichita. Okay, and my wife called me while I drive back home. And she's asking me, where are you? Okay, how far are you still away from home? Okay, and I saw the sign on the road. It says, I'm away from home. It's 150 miles. It's still pretty long. I need to drive 2 hours. Okay, yeah. And if I looking at my Google map, it may be more accurate. It's 147.2 miles. Okay. Well, there's some other more accurate the GPS satellite can show the number like a 147.162 miles. Okay, so what's the number I need to talk to my wife? So obviously I'm going to say 150 miles. Okay, very easy. My wife just want to know roughly numbers. But if I talk, I'm away from home is about 147.162 miles. She probably will pause there and think about. Are you getting sick? Okay, what else are you doing here? She don't need this accurate number, right? But this is the case that we just need a rough number. But in other cases, we need very, very accurate numbers, right? Like a SpaceX, they need to retrieve the rocket back to their landing zone. Okay, so they need a very, very accurate number. Otherwise, the rocket will go into the ocean. Okay, yeah. So very important. They need to calculate that very accurate. So that is why. Okay, we need to make sure I'm talking about banana and you're talking about banana too. Okay, I'm talking banana, you're talking apple, and then we cannot talk to each other. So that's why all the scientists, everyone, doesn't matter in chemistry, in physics, in math, they're using the same rules because we need to make sure everyone using the same system talking about the numbers. Otherwise, the whole calculation has issues, right? Yeah, very important. So that's why everyone should be in the same page. So that's why we make a rule. And this rule is called SIGFIG. That's it. Okay, yeah. So let's just review what's the rule it is. So rule number 1 for SIGFIG is all the numbers. Okay, I'm going to write this as a number. Okay, this is equal number. So all the numbers are significant. All the numbers are significant. Okay, which means all the number count as one SIGFIG. Okay, so 1, 2, 3, 4, 1,234. That's each of those are numbers. So those are all number. So we have a 4 sig fig on this part. Okay, 4 sig fig. So this is a means of that. Rule number 2 is talk about all zeros between numbers. All zeros between numbers are significant. Okay, all zeros between numbers are significant. For example, 1, 0, 0, 1. Okay, so we're having 2 zeros in between. Those 2 zeros count significant. So that's why also 1 also significant. So this guy has a 4 sig fig. And if we have a 1, 0, 2, 0, 3, and those are 2 zeros in between, so those are all count significant. So this guy has a 5 sig fig. And 1, 0, 0, 0, 0, 0, 1, of course, 0, 2. This guy has a 5 zeros in between numbers, also count significant. So 1, 2, 3, 4, 5, 6, 7. So we have a 7 sig fig. Now, those are the rule number 2. Are you clear? Okay, yeah. So we'll review those things. Number 3 is called a heading zeros. Heading zeros are not significant. Heading zeros are not significant. Only one case we have a heading zero, which is 0.00223. Okay, so the heading zero, I'm not talking about only the zero before the decimal. The heading zero is all the zeros before the number, before one number. Okay, so the first number shows in this is 2. So everything before that, that's all heading zero. And heading zero are not count as a significant figure. So in this case, we only have a 2 sig fig. Okay, yeah. So it doesn't matter how many zeros before those are all not significant for 0.00001. So in this case, we have 6 heading zeros. Though all not significant, so only 1 sig fig in this case. Are you clear? Okay, not just the number before the decimal, it's all the number before the number, or all the zeros before the number. So rule number 4 is confusing. This is talk about trailing zero. Trailing zeros are not significant. And then there's another part, unless decimal point is present. Okay, trailing zeros are not significant unless heading a decimal point is present. So what that mean? Trailing zeros, for example, 2020, and this number, they have a number 0 between 2 numbers. So this number is significant. So we know those 2 are significant. But the last 0 over here is not significant because if you're looking at here, there's no decimal point shows in the number. Doesn't matter where the decimal point, but this one do not have a decimal point. Okay, so this 0 does not count. So that's why this guy has only 3 sig fig. And if you're talking about 150, this number, since the last 0 shows over here, is not significant. You see, this guy, this 0 is not significant because there's no decimal shows over here. So only 1 and 2. So this guy has a 2 sig fig. You got it? Okay, yeah. But if you have a 2020 and you shows the dots, which is a decimal, shows up here. Sometimes people can write like this. Sometimes, but if you write a down 0.0, this is another. Now, this guy, the heading 0 will be significant since they have a decimal. So this guy has a 4 sig fig. But if you're looking at this one, this guy also has a decimal shows over here. So this heading 0, the trailing zeros are also significant. But this guy has a 5 sig fig instead of 4. Okay, yeah. But yes.
Well, shouldn't you already assume that there's a decimal after the 2020 already?
No, you cannot assume you have decimals. I mean, well, there's a suppose has a decimal, but the way you write is different. For example, if you write 2 or you write 2.0, this two numbers is completely different one way rate. Okay, because the value, if you see 2 and 2.0, the value of those two numbers is the same.
Yeah.
But the next value of the number is different. Okay, the next accurate number is different because 2, they only have 1 sig fig. So once you add 1, the most accurate, the next accurate number for number 2 is 3. Okay, but 2.0 has 2 sig fig. So the next accurate number is not 3.0. Definitely, this is not 3.0. The next accurate number is 2.1. So that is why the accuracy, the sig fig, very important because when you assume the numbers is different. Okay, yeah, very important in this case. So that's why we need to run those numbers carefully. Okay, especially when we do the experiment, you're gonna read those numbers, a lot of numbers, right? You read numbers, that means something. Okay, that means something. Okay. So let's just keep doing this. Okay. Again, 20.0, this means 4 sig fig, but it doesn't mean you always gonna have a 1 decimal after this numbers. If the decimal in between the number, it also counts. Okay, so it really doesn't matter where the decimal shows, but once you have a decimal and all of the trailing 0 will be significant. So this guy also has a 4 sig fig, but you're gonna say, wait, are you talking about this number and this number has the same value? No, I'm not talking about those two has the same value, but they do have a same sig fig, but they do not have a same value. The value could be different, but the sig fig could be the same. Okay, or you have a 0.2020. This guy also has a 4 sig fig, but definitely they have a different values. Are you clear? Okay, yeah. So generally, this is the rule for significant figures. Let's take a break, and then we're going to continue the topic. So usually we're going to have a several break in between the lecture. Okay, yeah.
Thank you.
No problem. What's your name again? Sorry.
Mariam.
Mariam. Yeah, there's a Y in there.
Yeah. No, it's hard. It's hard. Don't worry about it.
Okay. I'm not good at pronunciation.
No, it's okay. It's all right. I get it. How long is the break?
Huh?
How long is the break?
How
long is the break?
long is the break? Depends.
Sorry.
Well, probably like 2 to 3 minutes.
Okay.
Yeah.
You have 32.5 seconds.
Oh my god.
Well, I'm not going to have a countdown, okay? So don't worry about that.
It's counting down.
Oh, you made me confused.
Yeah, this room is really cold. I have no idea. So that's why they are always very cold. So now I'm going to already give you the blue study guides. Since we have 4 units, each of the units gonna have a 1 study guide. Okay, yeah. So that's gonna be color coded. So the first unit is a blue study guide. Bring the blue study guide every time because we're going to have some practice through the study guide. Okay, yeah. And also I'm going to give you the periodic table. And this periodic table is similar like the periodic table that you use for the final exam. And you're going to using this periodic table for the whole semesters. You can write whatever you want to mark the periodic table. That's up to you, okay? And you can bring this for the exams, but not the final exam. Final exam will have their own periodic table, but you can use that for the unit exams. Okay, yeah.
We can use it on the test.
Mhm.
We can use on the test.
No,
Oh,
only periodic table.
I got you. Thanks.
But sometimes I will add some of the questions from the study guide in the exam.
I think you can see the opposite of what that I said.
Okay, so let's come back. Let's come back. So now you already have the study guide. Go ahead to work on the page 5. Page number 5, question number 1. Okay, okay, to figure out all the sigfig for those numbers. Okay, figure out all the sigfig from those numbers. You can skip the I and the J. You can skip the J and the K.
Thank you.
Okay, so let's review it. 1A, that's 4 sig figs, B, that's 5, C 3, D 4, E 3, F, that's 4, G, that's 5, H is 2. Okay, 990. The 0 is trailing 0 do not have a decimal.
No
Okay, so
decimal, no count.
yeah, no decimal, no count. Okay, and the I is a 3. L, that's gonna be 3. Okay, so now we're going to talk about the J and the K. Okay, J and K. The J and the K is talk about scientific notation. Okay. Scientific notation. Generally, scientific notation is including 2 parts. The first part is called the number parts. The second part is exponential parts. Okay. So most of the case, if you count the scientific notation for the sig fig, you only count the number parts. Don't have to worry about this. Okay. So that's why if you're looking at the J, 1.04 times 10 to the 12 gram, that's a 3 sig fig because the number part is 1.04. So that's a 3 sig fig. And K, 5.59 times 10 to the negative 7 meter. And this is a 3 sig fig too, because the 5.59 is a 3 sig fig. Are you clear? Okay. But here I'm going to talk about a little bit about the scientific notation. I give you one example. For example, we have a 1.04 times 10 to the 12. You can also write 10.4 times 10 to the 11th, or 104 times 10 to the 10th, or 0.104 times 10 to the 13th. Okay, believe me or not, if you type those everything in the calculator, you should have the same value. Okay, you should have the same value. But I'm just saying, not all of this is count as a scientific notation. Okay, don't look at you have a number and you have a expandable part that's called scientific notation. No, only one part is called, only this one is called scientific notation. If you're looking at the number parts, the difference is the number parts have to be between from 1 to 10. Could be larger and equal 1, but have to be smaller than 10. So that is the range for the number parts. If you have a bigger number than 10, then does not count for scientific notation. It's a number, but not in scientific notation. Okay, yeah, are you clear? Very important, okay? So only this one is called scientific notation because this number is in between 1 to 10. Okay, yeah. So if you want to convert a number, for example, 2, 3, 4, 0. Okay, so if you convert this to a scientific notation, just need to know, okay, decimal always in the over here. If this not show the decimal, you're gonna put the decimal over there, and then that's a 1, 2, 3, 4. You move 4, so that's equal to 1.234 times 10 to the 4th, 10 to the 4th. And by the way, since if the original is 12340, and this guy has a 4 sig fig, so once you write number parts, you're gonna write the 4 sig fig too, because you need to keep the same sig fig for the number when you do the transition from the normal number to the scientific notation. Are you clear? Okay, yeah. If this is smaller than 1, like a 0.0023, again, you're gonna write the decimal is over here, then you move this to the right side. 1, 2, 3, and 4. Oh, wait, no. 1, 2, 3. Make sure this value should be in between 1 to 10. Okay, so now you got 2.3 times 10 to the negative 3. Okay, you're moving 3 times to the right, so you're negative 3. Okay, negative 3. Okay, a lot of people, they just write the 0.0023. Well, this is a correct number, but I just recommend you fill the 0 in before the decimal. In this case, this is easier for me to write the number. For example, to write the scientific notation, I just need to count how many zeros before that, and then I can just write how many number shows on the exponential parts. Easy, right? Yeah. All right. So this is a scientific notation. Okay, this is a scientific notation.
So I know there's a way you can do it in the calculator with like the E, but I forgot how to do it.
Yes. Okay. If you have a calculator, just let you know. Maybe in the future we may use it. If you're looking at the Excel, okay, the Excel, and in the engineering parts, they are not writing the scientific notation and the 10 to the something. Okay, they write 1.2 E and 2. 1.2 E2 means 1.2 times 10 to the 2, 10 to the second. Okay, so if you enter the value if you shows over here is 120. Okay, yeah, the E something, E with a number means 10 to the something. Okay, so if you have like a 1.2 E negative 2 means 1.2 times 10 to the negative 2 second. Okay, then this value should be just a 0.012. Okay, yeah, are you clear? So the E is usually used in the engineering parts. Okay, the people use, but in the math, I don't believe the math people using this sign, but engineering using this sign. Okay, yeah. All right, so the next part, we're going to talk about the how to round a number. Okay, how to round a number. Anyone remember what is the number for pi?
3.141596.
What else?
I don't remember. Like 4, 5. I don't remember.
I can cheat, there we go.
Yeah, you can just look it up.
It's like 14165.
I have no. It's like a song or something. Whoa.
So this is how much I can remember for the pi. Okay, yeah,
Wow.
I remember some, so that's why.
See your credit card number.
So anyway, this is the pi number. Okay, but obviously we don't need that much.
Right.
Okay, yeah, so we need to learn how to run those numbers. So to run this number, for example, totally, I think we have a 23 sig fig over here, but we don't need. We just need, for example, we need five sig fig. How to run this? What are you gonna do? You start from the biggest number, okay, 3 over here, and then you count from the right to the left to the right. 5 sig fig. So 1, 2, 3, 4, 5. You count 5, looking at the next number, which is the 6th. And if this number is bigger than 5, you run this 1, round it up. So the 5 becomes 6. And then you cut everything off. Okay. So that's going to be a 3.1416. So totally you have a 5 sig fig. Okay. So this is how you run. Okay. If we need a 6 sig fig, then again doing the same thing. 1, 2, 3, 4, 5, 6. And you're still going to looking at the next one, which is 7th. And this one is a 2, which is lower than 5. Then you don't need to round up, just cut it off everything. Okay. Then the answer will be just a 3.14159. Okay. So this it give your 6 sig fig. Are you clear? Okay. Yeah. So go ahead to write down what is a sig fig for 7 sig fig and 8 sig fig. Okay, for the 7 sig fig, you just count 1, 2, 3, 4, 5, 6, 7, and then look at the next one. Next one is 6. You round up, so 2 become 3. Then that's a 3.141593. Okay, so that's 7. 8, that's just 1, 2, 3, 4, 5, 6, 7, 8. And look at the next one. Next one is 5. You round up, so that's 3.1415. 927. Okay, 927. Are you clear? Okay, so this is how you run this number. But this is a run the number if they have a long tail of the decimals. So let's go back to look at if we have a sum of the numbers that do not have a decimal, which is a whole number. How can we run this? For example, 107. 107. 107. This guy have a 3 sig fig, but I just want to keep 2 sig fig. How do we keep it? Again, you can do 1 and 2. First 2, okay. Then the next one is a 7. Then what are you gonna do? You're gonna round it up, right? So you're gonna become 1 and 1, and this one also 1. The rest of those is different from the decimals. In the decimals, you can cut it off everything, right? But this one, you cannot cut this off from 107 to 11. Doesn't make sense, right? Yeah. So what are you gonna do? You're gonna write a 0, fill the 0. Or you can write scientific notation. That's fine, okay? This guy, 110 is 2 sig fig. But also, you can write a scientific notation. That's okay. Yeah, you can write 107, you can become 1.07 times 10 to the second. then you run this number with the decimals. Then that's gonna be safe. Okay, definitely you can run it. That makes sense, right? If you keep the two sig fig, that's just 1.1 times 10 to the negative time 10 to the seconds. Are you clear? Okay, yeah. So either way, okay. So that's why, let's see, we have a 3,235, and I want 2 sig fig. And also I want a 3 sig fig. So go ahead to write down those numbers, keep only 2 sig fig and 3 sig fig. Well, to be honest, if you write the scientific notation, maybe it's easier. Okay, yeah. But if you're just write a whole number, sometimes it's gonna be confusing. Okay, so let's looking at this. First, let's looking at if we convert that to scientific notation, that's just a 3.235, and you know the decimal is over here 1, 2, 3. You move it 3 times, so time 10 to the third, and then you run this as a 2. So 1, 2. Look at the next one, 3. So you cut it off. So that's 3.2 times 10 to the third. If you're 3 sig fig, it's just a 1, 2, 3. Look at the next one, there's a 5. You'll run up. So it has a 3.24 times 10 to the third. That makes sense, right? Okay. Or if you're just looking at this number, just like what we talk about, you count 1 and 2. Look at the next one is a 3. So you cannot run up. You're gonna cancel this, but you're going to fill zeros over here. So that's going to be a 3,020, 200, 3,200. That works for the 2 sig fig. And for the 3 sig fig, that's going to be 3,235. Again, 1, 2, 3. Then you look at the next one. Next one is a 5. You run up. So you should write a 3, 2, 4 over here and fill the next one with 0. And it still is working. Okay. Yeah. But just to let you know, if you're writing like this, sometimes it's confusing. So better to convert that to the scientific notation and solve the problem. Are you clear? Okay. All right. So the last part we're going to talk for today, that's gonna be the calculations with the sig fig. So we're going to working on the easy way, easier things, which is multiplication and divisions. Okay. Multiplication and the division, the key is we're going to keep the least sig fig. Keep the least sig fig. So let's looking at one of the questions in the page 5, question number 5. Okay, page 5, question number 5, 5A. It shows a 2.89 centimeter times 4.01 centimeter. Okay, so we have those numbers, and if you put those numbers together, you just put this in the calculator. That's 2.89 times 4.01. You got this number, 11.5889. But the point is, this is long. We have a lot of decimals shows up here. But to be honest, this number is not accurate, or this number is not accurate because we only have a 2 number given number. One is 2 decimal, the other, both of our 2 decimals. So generally, you shouldn't have 4 decimals. You shouldn't get. You only have accurate in the 2 decimals, and then you got a result that has a 4 decimal accurate. Doesn't make sense, right? Yeah. So to solve this problem, the rule is if you have this number multiplication and division, you're going to keep the least number of a sig fig, which means the first one has a 3 sig fig. This one also has a 3 sig fig. So once you have an answer, you're going to keep the least sig fig. So since both are 3 sig fig, you're going to only keep 3 sig fig over here. So 11.5889, keep 3 sig fig. That's gonna be 1, 2, 3. You look at the 5, then looking the next one is 8. So 8, you round up to 6. So that's gonna be 11.6 in this case. So 11.6 in this case. But again, this is chemistry. So always, when we calculate the number, we always has a unit. So the unit can also do the calculations. This is a modification, so unit will be involved. So generally the unit is just centimeter times centimeter. So that's why we call it as a centimeter square. Okay, centimeter times centimeter, that's just centimeter square. So 2.89 centimeter times 4.01 centimeter is 11.6 centimeter square. Okay, centimeter square. Okay, yeah. We can have another so division. Let's say 6b. 6b over here. They have a 24789.4. This is kilometer square divided by 43.5 kilometer. Okay, so we're going to have a numbers, but you can put everything in the calculator first. 24789.4 divided by 43.5. You got this number. Okay, but now we are having this one has a sig fig on the 6 sig fig on the top, 3 sig fig on the bottom. So definitely we're going to keep the least number of the sig fig. So we're going to keep 3 sig fig. So this number, if you keep 3 sig fig, then only just the first 3. 569.8. But I recommend you write this down, and then we can easily to cut. 569.87. Let's just leave this, and then we're going to cut this into 3. Well, again, if you want to write this easier, you can write scientific notation. Okay, yeah, or so if you write scientific notation, it's just 5.6987 times 10 to the second. And then you round this 1, 2, 3. And then looking at the next one is 8. So 8 become round up. So 9 becomes 0. 7 and 6 becomes 7. So you're gonna write it 5.70 times 10 to the seconds. 10 to the second, yeah. Are you clear?
And this has to be written in scientific notation, because if you round
Yeah,
first,
that's
then it's
true.
only 2.
Yes, that's true. If you write this, then it become 570. Okay, unless you got a point shows over here. But usually we're not just get a dots. Okay,
It's 2.
yeah. So better to write a scientific notation like this. That makes sense, right? And then if you look at the unit, this is kilometer square divided by kilometer. So kilometer times kilometer divided by kilometer. So generally it's just kilometer. That makes sense, right? So this answer is just kilometer. All right, so now pretty straightforward, right? Multiplication and division is just find the least number of the sig fig, the least number of the sig fig. Okay, but when we do the addition and the subtraction, that's going to be a little bit confusing. Okay, so that's why you need to do the practice on this. So addition and subtraction. Addition, subtraction, therefore the rule is keep the least decimals. Keep the least decimals. Keep the least decimals. So let's look at one of the question 2a. In the page 5, 12 centimeter plus 0.031 centimeter plus 7969 centimeter So now you add them together. The easier way, just put everything in the calculator and then you count then you're doing the rounding. Okay, so we're going to have this number 7981.031. Okay, and then don't forget the unit. Addition and subtraction will not changing the unit. So centimeter, that's going to be still centimeter. Okay, so those are adding together centimeter, still centimeter. Then we're going to round this number. Okay, so the rule is keep the least decimal. Least decimal. The least decimal means how many number of the digit after decimal point. Okay, how many number of digits after decimal point? So 12, there's 0 decimals. This guy do not have a decimal, right? So this guy, so this guy has 3 decimals. Again, I need to emphasize the decimals number is different from sig fig. Okay, decimal numbers is different from sig fig. Okay, and this guy, since this is a whole number, they do not have decimals, so this also have a 0 decimal. So now 0 decimal, 3 decimal, 0 decimal, they add together, they should have, we should keep 0 decimals, right? Because we're going to keep the least decimals. So this guy shouldn't have a decimals. Then that means we should accurate the number over here, right? We should accurate the number over here. And then you need to look at the next one. Next one is 0. So that means we are not going to round up anything over here. So you can cut off. The final answer will be 7981 centimeter. That's it. Okay, so keep no decimals. Okay, that makes sense. Okay, technically, to make things accurate, to make a number accurate, we usually gonna round a very small number. Okay, for example, if you have a 1, you're minus 0.001. 1 minus 0.001. If you're putting into the calculator, the number is gonna be 1 minus 0.001. 0.999, right? That's gonna be equal to 0.999. But if you're based on the rule, we're going to keep the least decimal. So this guy has a 0 decimal. This guy has 3 decimal. We keep the least decimal. Then what we're going to do? We're going to just keep 0 decimals. Nothing, right? And then that means we're going to just keep the number shows over here. Keep the 0. And then you look at the next one. Next one is a 9. That means you're going to round this up. So you're going to write 1 again. So technically, in the real things, to keep the number accurate, you have to face the problem. A big number minus a very small number actually is still the big number. Okay, they're not going to change any. Okay, so 1 minus 0.001 still equal to 1. Okay, so this is the fact. This is a fact. If you want to follow the rule, then that's the rule. Okay, yeah. Just like if you have add 1 drop of the water in a swimming pool, generally this 1 drop of water doesn't affect anything. It won't affect anything. Okay, to make the accurate the number, this small number won't affect this big number a lot. I mean, it won't affect the big number. So that's why you will see something like that. A big number minus a small number still gonna be the same number. Okay, yeah. Any questions? Okay, yeah. So this is pretty much I'm going to talk for today. Okay. For the study guides, okay, I hope you're gonna work some of this here. Okay, so this is try to help you to remember something. Okay, try to help you to remember things. Although I do give you the homework, but the homework is just a small, short period of questions. The study guide should have more practice over there. Okay, if you want to be successful in this class, this is what you have to do. Okay, yeah. And I recommend you do every day. Okay, so for example, you spend 20 minutes or 30 minutes every day instead of spend like 2.5 hours for a whole day. I mean, it's more efficient to do every day 30 minutes than doing 2.5 hours for one day. Okay, definitely. In this case, you're going to continue to repeat the same thing, and then you just remember. A lot of people said you need to remember one thing at least 7 times, then you can remember things. So repeating, do the same thing every day is kind of doing the same process, and then you're gonna remember it. Are you clear? Okay, yeah, something. Oh, by the way, 2.5 hours for study. I believe first hours you can say, okay, I'm going to study this. And after that, what's going on? What's the news on YouTube? Okay, yeah. Or let me just swipe some of the TikTok. Just several minutes. Then after that, 4 hours already passed. Okay, yeah. I did that. Believe me, I did that. Okay, yeah. So okay, so I'm done for today. And let's move to the lab. We will do some introduction in the lab.
You guys, everything I have.